Welcome to math class. We are continuing on the MathWorks 10 workbook looking at unit 4.2, which is mass in the imperial system. So we are looking at pounds, ounces, tons, all those kinds of things. So what we're going to look at first is we're going to look at the example on page 183. Oop. This isn't sliding for me. So 183. So what we have there is Manuela, who has, she's basically making fondue, and she's got a few different kinds of cheeses with a few different weights. She wants to know how many pounds of cheese does she need total. So she has 1 pound, 2 ounces of Gruyere. She's got 12 ounces. I'm going to use the symbol for pound as well instead of the word, just to keep this simpler. So the symbol for pound, 1 lb and 2 ounces. The second one, they have just 12 ounces. And the other one is 11 ounces. And she needs to know what is the total. So there's an important thing that we have to know right now. We have to know the conversions of the different measurements in the imperial system. So the first one we have is 1 ton. 1 ton in the imperial system is the same as 2,000 pounds. The second one we need to know is that 1 pound is equal to 16 ounces. And those are the important numbers that we need to know when we're dealing in the imperial system. So what we've got to do here, and the quickest way for us to do this is simply, or the way that I prefer to do it, is to simply add up the pounds and the ounces separately. So for instance, we have 1 pound, 0 ounces for that, so we wind up with 1 pound total. And we have 2 plus 12, which is 14, plus 11 gives us 25 ounces. And looking at that, I know right off the top that it is more than 16 ounces. So I'm going to go right away here. I'm going to take away 16 ounces here, and I'm going to add 1 pound here. What I'm left with is 2 pounds and 9 ounces. Okay. That is my preferred way to solve these types of questions, though there is another way to do it. The other way you can do it is to simply work in ounces. So if I take the same question, I've got 1 pound, 2 ounces, 12 ounces, and 11 ounces. So what I'm going to do is I'm going to take this 1 pound here, and I'm going to convert it into ounces, which, as I know, is 16. Then I add it, so what I wind up with is instead I get 18 ounces plus 12 plus 11 gives me a total of, gives us a total of 41 ounces. I know that it's more than 16 ounces. In fact, I know that it's actually more than 32 ounces, which is double 16. So what I'm going to do here is I'm just going to put that down before I start moving stuff. I'm simply going to start taking away 16s until there's no more left to take away. So 41 minus 16 is, and I'm going to add it over here. So that's 1 pound over here. So 41 minus 16 is going to give us 25 ounces. I'm going to bump my screen down here a little further as well, which is 1. I'm going to take away another 16 ounces, which gives me 2 pounds over here, and I'm left with 9 ounces, which I know is less than 16, so I'm just going to leave it. So what I have here is I'm left with 2 pounds, 9 ounces. Okay. Not overly difficult. The important thing to remember is the conversion between the different units. There's 16 ounces in a pound, and there's 2,000 pounds in a ton. That one we're going to use in a couple different examples. All right, that's the way you're going to solve the questions on page 185. Let's go ahead and look at our next example, page 186. So on page 186, we are talking about trucks and truck weights, which is where we're going to start using our tons conversion. So we have a fellow by the name of Arthur who has a semi-truck trailer. Sorry, the truck. Oh, they worded this kind of funny. So the truck is 8.7 tons. Oh, I think it's no S there, sorry. 8.7 tons. The trailer is 6.4 tons. And what they know is the total, or the gross weight, so total weight of the truck, is actually 21.3 tons after it's loaded. So what they want to know is how heavy is the load. So there's a couple things going on here. The first one is separating the weight of the truck from the total weight in order to figure out how much the actual load is. So the first thing I'm going to do is I'm going to add up 8.7 plus 6.4. Okay. I'm going to wind up with, carry the 1 here, and I'll wind up with 15.1 tons. Okay. Now they told me that after the truck was all loaded up, it's 21.3, so I'm going to go ahead and go 21.3 minus 15.1. I get 2, I believe 6.2 tons if I did my quick math right there. So I know that the load is 6.2 tons. The second thing they want us to do is they want us to convert from tons to pounds. Okay. So all I'm going to do here is simply multiply my conversion weight, which we already know here. I know that I've got 2,000 pounds inside every 1 ton. Right? So I have, what was our answer here? Sorry, 6.2 tons. And I know that for every ton in there, I've got 2,000 pounds. So I'm just going to go ahead, multiply this by 2,000, and I wind up with my total answer of 12,400 pounds. Okay. A couple steps involved in that particular question, but it's still not overly difficult. Basic differences math with the subtraction and then converting into pounds. So let's go ahead and look at the next example now on page 188. Extend a bunch of these down so I don't have to do that every time. Page 188. Too far. Okie doke. So now we are combining principles for page 188. We are using our pricing, actually our unit pricing that we covered earlier, as well as our measurement conversions. Okay, so we're going to be combining a couple of skills here. So what they tell us is that we have a 12-ounce can of vegetables. It costs $1.49, and then we also have a 1-pound 2-ounce can of the same veggies, which costs $2.19. What they want to know, which is cheaper. Okay. So if we remember from this point, this is unit pricing. So what I need to do is just determine what my total cost is divided by the unit. So in this particular question, if you've noticed, I have opposite units. or not necessarily opposite, but I have some different units. I've got ounces and I've got pounds. What I need to do is convert these into the exact same unit. I'm going to go ahead and take this one and I'm going to convert this into ounces. I know that there are 16 ounces in every pound. I know I have 2 ounces here. I add those together. I get 18 ounces at $2.19. In order to find my unit price, I divide my price by the number of units I have. So I get 219 divided by 18, and that gives me a total price of 0.12 ounce, basically 12 cents per ounce. We also have to do the other one. So now we've got 12 ounces at $1.49. So I'm going to divide this by 12, and I get an answer of 0.1242. I should be clear with this one. I actually get a total answer here of 12.17. Now, this is a unique situation because if we were to round this to 2 decimal places, I'm going to wind up with 12 cents for both of them, which means that they're the same price. For the vast majority of people who especially just working at home buying groceries, 12 cents is 12 cents. These prices are not different enough to really matter. However, let's say that you're a wholesale grocery supplier and you have to sell a few 100,000 of each unit. Now, 1/10 of a decimal place is going to start becoming much, much more important. So what we have to look at, or what we have to remember, is it's not always just about the individual consumer. We also have families that are, we also have businesses that are looking at these extra percentages in order to find their profits. Okay. So I originally tried to go to 2 decimal places, but I wasn't really looking at my example. So now that we see it, use all the decimal places. If it's not going to matter, then you're going to round to 2 decimal places. Okay. Unit pricing, pretty easy. Remember that we have to convert so that our units are the same, and then we just divide our price divided by the number of units gives us our price per unit. Okay, so let's go ahead and take a look at one more example, and then we can get out of here and move on. Okay, so on page 190, we have another pretty common situation. So anyone here that's, especially if you've ever hunted or anything like that, and you've had to harvest your own meat or something along those lines, if you've ever had to work in a restaurant and you've bought some meat and you've had to trim it down, the reality is most of the times when you buy meat, you're actually going to be trimming some off. So what we have here is a girl named Valerie who bought 4 pounds and 6 ounces of steak at $2.74 per pound. Okay. After removing the excess fat, so she trimmed it all off, all she was left with was 4 pounds of meat. What she wants to know is what was her true cost per pound. Okay. There's something a little bit funky going on with this question you have to be aware of. So remember, she bought this much at the supermarket at this price. The 6 ounces here is still being counted in her total. So I actually need to include this to figure out how much did she pay the first time. I need to know what that is. So in order to make this simpler on myself, I'm going to go ahead and convert that 6 ounces into a decimal. So I know that I have 6 ounces extra in this particular situation, but I know that there are 16 ounces in a pound. So I'm simply going to divide 6 by 16 in order to get my decimal. 0.375. Okay, so what that means is I actually have 4.375 pounds at $2.74 per pound. So in order to figure out my total, I multiply. I'm going to go here, pull up my calculator. 4.375 times 2.74 gives me a total of 11 point, oh, disappeared from my screen, 9875. Okay, that is the total price she paid. But here's the problem. She's not necessarily eating all of that meat. She's only eating what's left over after she trims off the excess. So we need to figure out, what did she pay for the actual meat that she ate? So I'm going to take this exact same number, $11.9875. Sorry, should have put that in there. Now I'm going to go ahead and divide this by what my actual edible meat was. So I had 4 pounds. So I divide it. What I wind up with is, let me pull up my calculator again here. So 11.9875 divided by 4 gives me a total cost of $2.9968. So 2.9968. Oh, it's way over here. Calculator's over there. 6875. We are talking about dollars and cents, so we're going to go ahead and round this up to the next available number. And what I get is, looking at this, so my 5 is going to round my 7 up to 8, which is going to round my 8 up to 9, which rounds my 6 up to 7, rounds my 9 up to 10, rounds my 9 up to 10, which brings my 2 up to a 3. And since everything else is 0, my final cost is $3 per pound is what she paid for the meat that Valerie ate. So that's it. That's all. I will see you in math class.